I have been working in Weber since 2009 already. So I look very young, thank you. But yeah, it's quite a long time already. So 14 years in the company in Saint-Gobain and in Weber. Whole this time I've been working with the facade products. So I was first appointed in 2010 for the sales manager for facade products, and since 2012 I've been working as a product manager for the facade products. I have been working with other product groups as well during this time, but facade has been the first one and the one I've been working with the most of the time, and this is something that I have done more than just selling materials. I have been working with the standards and guidelines in Estonia in like governmental level. So yeah, this is my life and my love, we could say. Michael's asked me to come here and talk about a little bit about the success in Estonia with our systems, and basically what I'm presenting today is basically two parts. First part, before the coffee break, I have the ETICS solutions in Estonia, which I'm going to talk about the standardization and testing process that we did years ago, and some benefits that our systems have, mainly the freeze-thaw cycles and the impact strength. And in the second part, I'm going to talk about the aquabalance technology. Have you heard about the aquabalance technology before? No? First time? The word is first time, or the technology, everything? Okay. Before I start, I just ask from you that who are here present right now. I understood that most of you are architects, but I think not all of you, or some people are from school, I understand, learning construction, builders. Okay. So basically, yeah, the things that I'm going to discuss today are maybe more for like architects and designers, the things that to consider when you are doing the projects. If I'm stuck somewhere, then I'm really sorry. English is not my first language as well. So, and if you have any questions, just raise your hand or ask, so that we will solve everything up and running. So, but ETICS solutions in Estonia. Do you know what ETICS means? In Estonia, we call it SILS. In English, it's ETICS, but yeah, it's different in different languages. So it means external thermal insulation composite system. And basically, when we are talking about ETICS solution, then we are discussing something like this. You can see on the screen. Yeah. Basically, you have some kind of substrate, some wall. Then you have gluing mortar and insulation. So there is no air gap anywhere. This is one of the most important characteristics for ETICS solution. On top of insulation, you have the base coat renders and some kind of decorative render. So this can be done with EPS boards, with mineral wool boards. Michael's discussed about the phenolic boards, so there are different options for the insulation material. In 2015, we were sick and tired in Estonia that we are using systems from all over the world, and we don't have actually the very valid certificate for that. So in 2015, we started with our former name, with Saint-Gobain ehitustootted, which means construction products in Estonia. We started ordering from Finland, from VTT, some certificate and tests for these two systems with EPS and mineral wool. So WeberTherm and WeberMin. I think they are under the same name now, sold in Latvia as well, yeah. So, and altogether we got this two certificates. We got one certificate for the WeberTherm system with EPS, and the other one for WeberMin system with mineral wool boards. So it was quite a task for us, because we are producing some products in Estonia, mainly base coat products. Then we are also ordering a lot of products from Germany, as you can see here on this fancy little advertise that Michaels have done. In this is our Estonian product, WeberTherm 310, that is base coat render. And the decorative renders in the buckets are always from Germany. So I'm not 100% sure all the products that Michals is selling right now in Estonia, but in Latvia. But yeah, the certificates that we have are combined with Estonian materials as base coat and gluing mortars, and German products as the decorative products, all the paints and renders. I also mentioned here the Finnish know-how from Finland. All our recipes that we produce in Estonia are from Finnish laboratory, R&D laboratory, because in Finland we have this so-called facade competence center in this region. So all those best products that we use are always coming from Finland, the recipes. And as you can see, yeah, this project has a pretty high cost. So testing two systems, only testing two systems, is 70,000 euros. It's about 30,000 for one system. So if you want to add one product to this certificate or change layer thickness or something, you need to do all those tests again. So therefore, it's not a cheap thing to do, and it was a pretty big project in for let's say Baltic states, where the turnover is not that big maybe as it is in Germany or France or somewhere mid-Europe. And now, two main benefits that we have from our systems. First of all, free store cycles, which is coming from Finland. I think Michals mentioned something about free store cycles also in his presentation. And maybe a little bit about the background. Standard certificate for the ETICS system says that you need to test 30 cycles only. And this 30 cycles is done so that you, first of all, you take the sample, the specimen, you expose it to the water, then you are heating it up during 8 hours up to 25 degrees. So this is like the warm cycle, and then they freeze it down to -20 during 16 hours. So you get this like freezing cycle. And then they do it 24 hours one cycle, they do it 30 times. So this is the standard ETAG, this is European Technical Approval Guideline 004, which is the old facade standard. This is the old way how to do it. What we did, first of all, we tested our base coat render that we are producing in Estonia, this 310. We tested it according to the Finnish standard, the SFS 176, to 100 cycles. This is the Finnish norm. And after 100 cycles, you need to have this compressive and flexural strength at least 2/3 from the initial value. So it's around 10 megapascals at first, then you need to have it at least 7 megapascals after the 100 free-store cycles. Because this test was successful, then we decided that we're going to do 100 test cycles for the whole system as well. And even that was a great success. So this is basically the only system in Estonia today that is tested according to the Finnish standard, like 100% for 100 free store cycles. So this has been pretty good sales argument in Estonia for us, because we are in Nordic region. We like to say, I think you also like to say that you're a Nordic country, Scandinavia even sometimes. So yeah, we always say about the Nordic climate and the extreme weather conditions that we have compared to, let's say, Germany or France. So yeah, that's one benefit that we have done. The other thing is the impact strength. And this is something that comes from this first point actually. To get better weather conditions or weather characteristics, the free store cycles, we always insist a little bit thicker layer thickness, at least 5 millimeter. With this 5 millimeter layer thickness, which is more than usual, we understood that we also have pretty good impact strength. We did some extra tests there as well. First of all, I talk about impact strength that we have on EPS boards with special render. I don't know, is it sold ever in Latvia, but it's been a pretty good product in Estonia years ago, but now they don't use EPS anymore that much. Therefore, we are not selling it anymore that much as we sold it like 5 years ago. But there is a product, organic base coat. It's not cement base as 310. It's called 377, and we import it from Germany. So if you use the standard one layer reinforcement, then you get 15 joules of impact strength. standard solution usually gives you 10 joules. I come back to this on the next slide of what 10 joules means. If you do 2 layers of standard mesh and then the same only 3 mm layer thickness, then you will already get 30 joules, which is 3 times more than standard system for WeberTherm or WeberMin solution or any other which we have on the market from any competitor. And if you use 2 layers, but only first layer with the standard mesh and the other one special so-called panzer mesh, then you will get already 60 joules, which is 6 times more than the standard. So then we realized that this at least 5 mm layer thickness gives us pretty good impact strength, better than we were actually trying to achieve. And what it means, with standard 1 layer base coat with 1 layer mesh and 5 mm layer thickness, we achieved pretty good values. But for you to better understand what those values are, I'm going to tell you about 3 different categories that ETICS is telling you. One of them is category 3. It's 3 joules. Nobody uses that anymore. It's way past in history. Mainly used, second category, gives you 10 joules. Does somebody know what 10 joules impact strength is? How much it is? I'm talking about some figures, but nobody knows. Is it like this, or is it like this, or by foot, or what does it mean? I'm going to tell you about the testing method. The testing method is that you take 1 kilogram steel ball and you let it fall from 101 centimeters. So basically from 1 meter. This is one way to test 10 joules. If you want to test 30 joules, you take this same 1 kilo ball and you let it fall from 301, from 3 meters basically. Or other way is to take 3 kilo steel ball and let it fall from 1 meter. It makes the same. So 10 joules is 1 kilo steel ball from 1 meter up your toe. You can test it at home. I tell you, it's not nice. So yeah, actually this second category is already pretty good. This is the standard norm that we are usually insisting. I have this little mark here, which means that for the second category, you can have a small crack in the decorative render, but this crack can't go through the whole system. So it can't go through the reinforcement render, base coat render, and also the mesh. So the system has to be stable, but it can have a small detachment or crack in the decorative render. The first category is the same, 10 joules, but this has to be absolutely perfect now. And before, everybody thought that second category is achievable only with double reinforcement mesh and double the layer thickness as well. So it's not reachable with the standard solution. So we did the standard mesh, standard 1 layer base coat, standard tests. We're trying to achieve the second category, and what we did was actually surprising. With the EPS system, we got the impact strength with all the polymeric decorative renders. The 481 is silicone-based decorative render, and 471 is the siloxane-based decorative render. Both are like premium products, and with them we got the first category. And once again, this is with the standard solution, which is usually in Estonia, at least, if you have in project that you have to have the first category, then usually you have in the brackets that you have to use double reinforcement or some special solution for that. Now you can have the standard solution to get this first category. So that's a pretty good benefit as well, mainly for like renovation market, block of flats and job sites like this. With this mineral decorative render, we had the second category, which is like the standard solution, and it kind of makes sense because the mineral-based decorative render is more rigid. It's not that elastic. What was even more surprising was the solution on mineral wool. With mineral wool, we had the second category with the elastic polymer-based products, and first category with mineral decorative render. So vice versa from the EPS solution, which was very surprising at first, but then we realized that it actually kind of makes sense because of the difference between the EPS and mineral wool. Now here comes the part that I not sure am I able to translate into English, but the problem is that EPS will take the impact pretty much on this small area where the impact is coming. But with mineral wool, we have actually mineral wool guys in the room. With mineral wool, you have this dynamic strength or dynamic load-bearing capabilities, something like that. Sorry if the translation is not perfect, but it will divide this impact on bigger area. And therefore, this rigid mineral decorative render works pretty good. We understood that on mineral wool, we have pretty good impact strength with standard cement-based base coat render 310 that we are also showing today. And we thought that, okay, let's try, let's do some extra tests and let's see what impact strength we can achieve. On EPS, the only solution was to use this organic render, which costs about 10 times more than the cement-based base coat render. So therefore, we thought that if we could find some cheaper solution with our own mineral-based base coat, then it would be a huge benefit. And what we did 2 tests on what we called a standard mineral wool back then. It's not on the market anymore, unfortunately. We tested it with Parhak Lineo 15. Now they have Lineo 10 only, but on impact strength-wise, I think there is not a big difference, to be honest. We used the base coat, our own 310. We used the double mesh. We actually copied the same solution that we have for this EPS system with the organic render, just used the mineral wool and mineral base coat and just wondered what we would achieve. Layer thickness is of course much thicker than it is for the organic solution, so the base coat layer thickness is at least 8 millimeters. With the decorative render, it's approximately 10 millimeters, 1 centimeter. So it's a little bit thicker than the standard solution. And we tested with different, let's say, polymeric products. 471 the siloxane and 481 the silicone renders. And the result was absolutely surprising. We achieved over 30 joules of impact strength on mineral wool with our own standard products. A lot cheaper products than those special organic renders that we use for EPS or what some competitors are providing today. And then we thought that, okay, let's go for the maximum, and we did the same basically. Mineral wool is the same, base coat is the same, layer thickness is the same, decorative render is the same. Only thing we used as the second layer of mesh, we used this Panzer mesh, this stronger one, 475 grams per square meter, and we achieved over 50 joules. So we couldn't achieve actually the 60 joules that we have for the EPS, but to be honest, 50 joules is pretty good already. In Germany, they have this TIN normative, the standard for impact strengths, where they have different like hail and football and stuff like that tested. And they say that actually around 35, maximum 40 joules are the impact strengths that the facade or ETICS has to bear that are like so-called accidental, like hail or football. If you want to have a facade that is capable of bearing some vandalism, then basically you can say that you don't get this kind of ETICS. If you want to harm the facade, or if you ride into the facade with your car, then probably this ETICS solution is not the thing to survive that. But on standard problems, this 30 joules is usually more than enough. As I told before, 30 joules is 3 kilo steel ball from 1 meter, or 1 kilo steel ball from 3 meters. On your toe, you can go home and test if you want to. I wouldn't suggest. But yeah, that's the load, and it's pretty decent load, to be honest. We started tests in 2015. Testing part was maybe up to 6 months. I don't remember exactly. As you saw, this three store cycles already took 30 days. 100 days altogether. So it's over 3 months. But the certification process, we did the tests in VTT in Finland, but the certificate was from a third body in Sweden, which was SP. Now it's called RISE Institute. They just changed the name, and they are extremely slow. If you want to do something really slowly, do it in Sweden. Sorry, I didn't see you filming.